Here we go, a quick run through of some topics from chapter 3, polynomial functions, power functions, and quadratics as we go along. Obviously hit pause where you need to. Here we have function notation, so a function where I have a variable raised to a power of some kind of like x squared or x cubed. This would be what's considered a power function. When your variable f of x equals a to the x, where a is any number, any constant, x in the exponent, that means that this is an exponential function. So power function, exponential function. And then when we're going to talk about things like in these types of equations, mostly we're going to be talking about power functions here at the beginning, but what's the long run behavior? That is, if I were to make a graph of this equation, x to the fourth, the question is, what does it do in the long run? All right, and if I were to graph that, it would look something like this. That is, as x approaches negative infinity, f of x approaches positive infinity, because it goes up forever and ever. As x goes to the negative, this goes up forever. As x moves to the positive, it does the same thing. So the end run behavior for both of those is it goes up forever and ever. If I look at that second equation and graph it, this one here, the g of x, it is a negative x to the fourth, which means it inverts it. So in that case, as x approaches positive or negative infinity, the function itself also approaches negative infinity because it goes down forever. I also know that because it's an even power, that means both ends are going to do the same thing. So if one end goes up, the other end goes up. With an even power. With an even power here, I know they go in the same direction. The negative coefficient means it's going to go down, so both are going down. And then as we look at this, we're going to talk about all these different things. When we talk about terms, 3 is a term, 8 is a term, negative 3 is a term. 3 is a term, 8x squared is a term, and negative 3x cubed is a term. I have 3 terms in this one. So this would be called a trinomial. Coefficients are the numbers in front of each term, or the constants. So negative 3 is a coefficient, 8 is a coefficient, 3 is a coefficient. The leading coefficient is negative 3. And again, this is going to determine direction. And then the highest power is my degree of the function. So this would be considered a third degree polynomial. Third degree polynomial, odd functions. So it's an odd number as the highest power. So if the degree of the polynomial is odd, that means one end of the function goes up, the other one goes down. And you can figure this out pretty quickly. If I put in a really, really, really large number for x, 1,000, cube it, much larger number, times negative 3, it's going to be negative a really large number. So if I'm thinking about a graph of this again, when I get out to 100, it's going to be way down low on the graph. And it's going to keep going down. So as x approaches positive infinity, my f of x will approach negative infinity. And if I put in a really, really, really large negative number, so negative 1,000, cube it is going to be also a negative number times negative 3. So now I have a negative times a negative, it's a positive. So at that end, as x approaches negative infinity, my f of x will approach positive infinity. All right, so a cubic function, although that's not exactly how this one looks, it will have an appearance of something like this. If it were a positive leading coefficient, if that first number was a positive 3, then I go to graph this function, and it would look something like this. Where one end goes up, the other one goes down. Roots and zeros are fancy ways of saying, where does my graph cross the x-axis? Wherever it crosses the x-axis, that is a root. It's also a 0. It's called a 0 because at that particular x, the y-coordinate is 0, hence it's called a 0. Now we're looking at quadratics. Here's the general formula for a quadratic, ax squared plus bx plus c, where a, b, and c are any positive or negative integer, or really any positive or negative number. X is my variable. My highest power is 2. It makes it a quadratic. This is also a trinomial. There are 3 terms. This is one format. You can also you can also write an equation in this format. This is what's called vertex form. Because if I look at this, whatever number is h, that's the value of the x coordinate of the vertex. And k would be then the y value of the vertex. And what do I mean by that? So just recall, a quadratic is a parabola. And wherever the h and the k are, I would put it right there, h comma k. And as long as my a is positive, it's going to be a parabola that opens up. Depending on the numbers will depend on where it intersects. So this would be a 0, that would be a 0 because that's where it crosses the x-axis. And then this value right there where it crosses the y-axis is its y-intercept, which also happens to be the letter c. Because if I put 0 in for x, because that means I'm on the y-axis, my coordinate would be 0 comma c. That would be the y-intercept. You can convert back and forth between the two. These are not formulas that are typically used often, but if you memorize them, you certainly can use them pretty easily. If you want to find out the b value, but I'm given this equation, I can put in -2 and then whatever the letter is for a, whatever the letter is or the number is for h, put those in will give me b, and I can do it vice versa. If I want to find h from my original equation, it's -b over 2a. We're going to see this and use this more commonly because then this will also be my line of symmetry. Once I know my line of symmetry, I plug that number into the original equation, and that will tell me the y-coordinate of the vertex. And then we have this. This is for completing the square. A very useful tool that I don't see many classes or teachers or classrooms using so much in the past, but is super helpful. So what we have going on here is here's my original quadratic. So what I'm going to do is I'm going to group my x values together, just with a parenthesis so you can see it here, leaving my constant number 14 off to the side. Then the first thing I do is I'm going to factor out anything that's in front of the leading coefficient. So my leading coefficient is 2. I'm going to factor that out in front. So I have 2 times x squared minus 6. I just factored the 2 out, reverse distributive, plus the 14. And then here's what completing the square means. I'm going to take that middle number, -6, split it in half, -3, square it, 9. So I'm adding 9 to this equation, but since it's times 2, I'm actually adding 18. So as to keep my equation consistent, if I add 18 here, I'm going to subtract 18 outside of here. So that way, if I were to remultiply this out, the plus 18 from 2 times 9, and the negative 18 would add to 0, giving me the original equation. So nothing's changed. This then, I recall from all my factoring I did in my past algebra classes, this will factor into x minus 3 quantity squared. X minus 3 times x minus 3 is this factored out. And then 14 minus 18 is -4. And that means, oh, now I have vertex form with my h and my k value given there. So my vertex in this case would be 3, -4. All right. And then for this one, we're going to find out that you can't actually factor it, and we want to find out the zeros. So if we start by saying let's start with this. What's the y-intercept? The y-intercept of this equation is -4. It's the constant number. It's the one without a variable. And then if I want to find the other zeros, I want to find out where this is equal to 0. And we could derive it if you want. I'm not going to. But we're going to use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Plug in the a, b, and the c. So -b is -4 because b is the middle term. That middle term is +4, so it's -4 plus or minus the square root of b squared, so that'll be 16 minus 4 times a, which is 2, times c, which is -4. All over 2 times 2, -4 plus or minus square root of 16, and it's minus a negative, so it's plus 32, all over 4, which will be -4 plus or minus the square root of 48 over 4, And then I recall back to a long time ago when we had to simplify radicals. Square root of 48 is equal to square root of 16 times square root of 3, because 16 times 3 is 48. Square root of 16 is 4. Square root of 3 is prime. I'm left with down here negative 4 plus or minus 4 root 3 over 4. I now have a 4 divisible into every single one of my terms. It divides there. I am left with x equals negative 1 plus or minus the square root of 3. Those are the two places on the x-axis where my equation goes through the x-axis. They're my zeros. And then up here is where it intercepts the y-axis. From those three things, I can plot another point symmetric across the center, and I would have then several points that I could graph. There we go. Quick intro into polynomials, power functions a little bit, and quadratics, quadratic equation. Yeah, there you go, folks.